wrapping up the answer to question or example number 3 about the soda can. So we found that the cube root of 20 over pi is a minimum radius, or a radius that gives you a minimum surface area. And so we're just going to sort of finalize the answer and say r equals the cube root of 20 over pi creates a minimum surface area because S surface area, the derivative of surface area, changes sign from negative to positive. Our conclusions are therefore, what do we want to find? We want to find the dimensions. So our conclusions, the radius is the cube root of 20 over pi inches. That is approximately 1.853 inches. And the height is 40. I'm going to use this. Is 40 over pi times this cube root of 20 over pi squared. All right, evaluating that on the calculator to find an estimate, we would get 3.706 or 3.707 inches for the height. Okay, that is the answer to question number 3. Let's take a look at example number 4. Okay, example number 4, a rancher has 200 feet of fencing to enclose 2 adjacent rectangular corrals as shown in the figure. What dimensions should be used so that the enclosed area will be a maximum? All right, so he wants to have the largest possible area for the animals he's going to put in that corral, and he has 200 feet of fencing. So here we're talking about perimeter, but here we're talking about area. All right, our goal is to maximize area. So we need an area formula for this corral. Looks like it's 2x by 1y. So area is 2x times y. All right, our secondary equation is the perimeter equation. Okay, and every one of these lines is going to be some fencing. So it looks like we have 4x plus 3y has to equal 200 feet of fencing. Okay, so in order to maximize area, we're going to need to take the derivative of the area function. That means I would like the area function written in terms of only one variable. Let's take the perimeter equation and solve for y. So 200 minus 4x divided by 3 will be y. So my area formula therefore is 2x times 200 over 3 minus 4 over 3x. All right. I could use the product rule, or I could just multiply this out, and that might be easier in this case. So I'm going to call it 400x over 3 minus 8x squared over 3 All right, we'll take the derivative from here. So the derivative of area is 400 over 3 minus 16x over 3. That's a nice linear equation. So a prime is equal to 0 when 400 minus 16x is equal to 0. All right, I'm going to divide both by 4. Get 100 over 4, which I can divide again. So x is equal to 25 feet. Okay, I'm hoping that the 25 feet is a maximum. I'm going to create a maximum. So let's create our first derivative number line. And put our critical point of 25 on it. That's a 0 on my derivative. This is a negative linear function for my derivative. So this is a negative linear function. So that means the derivative is positive and then negative. So I know at x equals 25, we have a maximum area. Because a prime changes sign from positive to negative. Therefore, x equals 25. And y equals 200 minus 100, or 100 over 3. So x equals 25 feet and y equals 100 over 3 feet, 33 1/3 feet, will produce a maximum. All right, have I answered the question? What dimensions should be used so that the area is maximized? 25 by 100 over 3. Now the whole corral is actually 50 by 100 over 3. But they just said what are the dimensions, and so we'll go with the x and the y dimensions. All right, make sure you state verbally what your number line is telling you. So the number line is a good organizer for your thoughts, but make sure you state it in words and answer the question. Okay, that is the end of the students' notes for optimization on 4.3 and 4.5. And there is a optimization homework worksheet that has 6 questions on it that you should look at next.